Stanford University.
Okay, well, welcome to Lecture 6 of Stanford CS 193P, fall of 2017. So today I'm going to continue that demo that I started last time. It's going to be a gigantic demo today, covering mostly stuff having to do with custom views. Then I'm going to come back to the slides, just a few brief slides on multi-touch and how we do that. And then we'll go back to the demo and add some multi-touch gestures to our little playing card thing. Here's the old slide of what you're going to learn today, which you go back and look at this slide after the demo and try to decide, oh, did I learn that? Well, we're going to find out. By the way, between last lecture and this lecture, I went ahead and finished off the custom string convertible for all three of these things. I just made suits custom string convertible return its raw value. Remember, its raw value are these little equals things here. And then rank, I had to actually implement a little description right there where I returned A for the 1 and then a string version of the number or the kind J, Q, or K. But once I implemented custom string convertible on all three of these things, then this code we had back here where we just printed out 10 random cards, that prints out a lot nicer on the console. So let's take a look and see what it does now. See, it just prints it out here as kind of an abbreviated version, which is, you know, if you're debugging, it's a lot nicer to be printing your cards out and seeing that. And you might want to do the same thing in your assignment number 3 as well. So that's it for that. We've completely finished our model for this MVC that we're building here, this app, this playing card. So we have a deck of playing cards. And so now it's time to dive in to drawing these cards. And we're going to do that with a custom UI view subclass, which is, I'm going to call PlayingCard view. Now, you create a custom view in the same way that you create other classes. So you're going to do File, New File. But here, instead of picking Swift File, which is like a UI independent thing, you're going to pick Cocoa Touch class. And that's because our UI view is a subclass of a Cocoa Touch or UI kit class. So I'm going to call it PlayingCard view. It's going to be a subclass of UI view. A lot of other UI kit things can be subclassed here, but the one I want is UI view. And it says where you want to put it. By the way, I just want to remind you all, some of you are putting your files up here at the top level, the project level, so they're ending up like next to your Xcode proj right there. You really want to be putting them down a level in here. This is where we collect all of our classes. So just a little reminder there. We're seeing that on the homework. And so here's my UI view subclass. Look at this, see? Subclass of UI view, that's great. And it even gave me a stub of a very important method here, which of course is our drawRect. Now, you notice this is commented out in the stub. That's because this iOS actually looks to see if you have a drawRect. And if you do, it makes an off-screen buffer for you and all kinds of preparations for you to draw. Okay, and that's not cheap, it's not free. So if you don't actually draw in your drawRect, then you would want to leave it commented out. Now, why would you ever have a UI view or UI view subclass that doesn't have a drawRect? Well, that's actually quite common. You do all your drawing with subviews. Consider UI stack view, right? It's a UI view. It does all its drawing with views that are stacked inside of it. It doesn't do any actual drawing itself. It has no drawRect, right? But we are going to have a drawRect, of course, because we're going to be drawing a playing card. Now, I'm actually, just for example purposes here, I'm going to draw some of my card with subviews and some of my card with this drawRect. Okay, so that way you'll get to see one view that actually does both. And in your homework assignment, you're probably going to have at least one view that does subviews and at least one view that has a drawRect. So you'll be able to see all that in action here. All right, so we got this playing card view. Let's go back over to our storyboard right here and put a UI view, a playing card view, basically, into our UI. Okay, so how do we do that? Well, how do we put views in our UI? We go over here to Utilities and down at the bottom, maybe we drag out a button or we drag out a label. And of course, where is playing card view? Well, it's not in here, of course, because these are all just the things that come with Xcode. But I can drag out towards the bottom here this guy, view, which is a generic UI view. So I drag him out here, and his class or his type is just UI view. I'm going to make my background a different color so we can see him a little better there. So I'm just going to select my background and change it to, oh, orange. I love orange. There's orange. San Francisco Giants colors right there. So here's my kind of generic UI view. Now I don't want this to be a generic UI view. I want it to be a playing card view, okay? Because that's what I'm working on. And the way we do that is with a different inspector on the right. You see, we've been using this inspector right here, the attributes inspector. Well, right next door to it is this guy. This is the identity inspector. And it inspects the identity of the selected thing. So here I have a view selected, and it's of type UI view. You see the class? But I can go here and change it to be a playing card view. So now this is a playing card view. And anytime the system needs to draw it, it's going to use our drawRect right here. It's the code that we've written. Okay? So that's awesome. Now, I'm going to do a little bit of auto layout here that you've seen before. So this is nothing new, but I'm just going to put this up in the edge here, put this one down here, and I'm going to pin it to the edges. So my playing card is going to be kind of tall and thin in portrait mode and kind of short and wide in landscape mode, but that's okay, we'll fix that later. So I'm just going to drag up to the corner and set my leading and top spaces to be pinned, and then I'm going to control drag down to this corner and set my trailing and bottom so that it's tied there. So now, if I go into landscape mode right here, you can see that it pins to the edges, so I have this funny shape. Now, I'm doing this mostly at the start here because I just want to show what happens inside your view when your bounds change. Because here, when we rotate, our bounds are going to be changing very dramatically from tall and thin to wide and short. So before we dive into doing a playing card, I'm just going to do a little bit of drawing, show you how drawing works with core graphics and UI Bezier path like we talk about in lecture. So let's first draw a circle, just a circle in the middle of our view using core graphics. Okay, see what that code looks like. So in core graphics, we always get the context first. We can't draw in core graphics without a context, and we get that in our drawRect by doing this UI graphics get current context. Now, this could return nil. That's why we do if let, but it will never return nil inside your drawRect. Okay, it might return nil in other contexts, but in this environment, it's always going to return. So, but we're still going to do if let right there. We could do exclamation point, but we're just going to do if let. So now that I have a context, now I can tell the context to do certain things, move to, okay, I can do move to, I can do add line to, things like that, add curve. I can add these things that basically are drawing a path, right, like a line moving around. So I'm going to make a circle, so I'm going to use one called add arc. Okay, and add arc is kind of cool. It just like takes a point and then circumscribes a big arc around a circle. And I'm just going to use that to go all the way around and create a circle. So when add arc is creating a path, it wants to know what's the center of this circular path that you're going on. And I'm going to make it be the center of my drawing area. And what rectangle specifies my drawing area? Bounds. Okay, my var bounds does that. So I'm going to create a CG point here, whose x-coordinate is my bounds midpoint. And I'm going to create the y-coordinate is my bounds midpoint in y. So I'm specifying right in the center of my drawing area, which is my bounds. The radius, I'm just going to do 100 points, nice big circle. The start angle and end angle here are in radians, not degrees, not 0 to 360. It's radians, 0 to 2 pi. Does everyone know? Raise your hand if you know what radians are. Okay, everybody, great. So 0 to 2 pi. And 0, by the way, is off to the right. Okay, 0 is not straight up, as you might imagine. It is off to the right. So I'm going to start off to the right, and I'm going to go all the way around my circle. I can go either clockwise or counterclockwise. Doesn't matter, because I'm going all the way around. So how do I go around? Well, that's 2 times pi, and there's a really nice little constant here, cgfloat.pi. Okay, that's how I can get pi in as a CG float. And I can go clockwise or counterclockwise, it doesn't matter. All right, so now I've created some path, some drawing here. So I can do other things in my context, like I can set the line width, for example. Not the line cap, how about the line width? 5 points wide. That's a reasonably thick line, not super thick, but reasonably. I, of course, can set the colors I want to draw with using these static vars in UI color, like, let's say, green for our set fill. That's our favorite fill color. And UI color.red for our stroke color. Okay, so I can set whatever colors. And then I can ask the context, for example, to stroke the path. So let's do stroke path here. And you'd think I could then say context fill path. Let's see if this will stroke and fill, and it won't. And the reason for that is that when we draw in a context, it's actually slightly different than using that UI Bezier path I showed you in the slides. In the context, when we do a stroke path like this, it consumes the path. Okay, it uses up the path. And so when we do the fill path on the next line, there's no path. We'd have to start again. So that's one of the big advantages of UI Bezier path. So let's do this exact same thing here, but using UI Bezier path. All right? So I'm going to say let path equal a UI Bezier path. We'll start with an empty one. I'll show you later how to create a Bezier path that starts with a path. And then I can do the exact same things, almost exact same methods as above. In fact, I'm going to copy and paste this exact same code right here. The names are slightly different in UI Bezier path, but they're doing exactly the same thing. Like line width, you don't say set line width, it's just a var on that object, so you set it to 5.0. You still set your colors by doing this. And here the difference though is I can say path.stroke, okay, and that path, that UI Bezier path still exists as an object, so I can say path.fill. I could also move the path over or shrink it down a little bit and stroke it again. You see what I'm saying? So I can use this path that I built, this arc, over and over and over. That's the whole point of kind of building it in this struct here, or this class, UI Bezier path. So we'll get rid of that, and let's see what this does right here. And it's going to be very similar, but of course it's going to stroke and fill that path. Oops, did I not press play? Okay, there it is. You see, stroked and filled there. All right, now, while we're here looking at a circle, I'm going to do something interesting. I'm going to rotate this phone to landscape. And what shape do you think we're going to have here? Anyone want to guess? Unfortunately, not a circle. Okay, we want it to be a circle, but it's an oval. Okay, so why did we get this? Because by default, when you change the bounds of your view, it just takes the bits and scales them to the new size, okay? Which sometimes that might be what you want, but a lot of times this is definitely not what you want, right? So how do we stop this? Well, what we wanted to do is to call this code again when we change our bounds and have us draw the circle again in the new space. So how do we do that? Let's go back to our storyboard here. Take a look at our view. If we inspect our view, at the very top of the inspector, the very first thing is content mode scale to fill, right? So it scales the bits to fill when the bounds change. And we want to change that to be redraw. So content mode redraw means call my draw rect again when my bounds change. So now, when we run, we get to see our circle. And when we rotate to landscape, it's going to redraw and thus draw it as a circle, which is what I intend. That's what our drawing code does. It draws a circle. Okay, so that's important to note, especially in your homework. You're doing these set cards. You got your squiggles and your diamonds and all that. If your bounds were to change in a set card, you wouldn't want it to like squish it into some other shape. Okay. All right. So that is enough of kind of taking a look at drawing with core graphics and with UI Bezier path. Let's settle down now to drawing a card. Okay. Now, what are the parts of a card? We've got the corners, right? The corners of the card, which is the rank and the suit in the corners. In the middle, we've got either a face card image of some sort, or we've got a bunch of pips. Those little things are called pips, the hearts and clubs and diamonds. We've got a bunch of pips in there, okay? So that's how we got to build our card. But actually, the card has another thing, which is it almost always has rounded edges, right? If you ever play cards, you don't want sharp edges because it catches on things and stuff like that. So you want nice rounded edges. So let's start by drawing the background of our card as a rounded rect. Now, you actually know how to do this using the layer of a UI view, which was in assignment 2 hints, but I'm going to draw it directly using a UI Bezier path. Okay, so I'm just going to say here, let path, actually I'll even call it a rounded rect because that's what I want in my background, equal UI Bezier path, and I'm going to use a different constructor than I used before, and you see there's a lot of them, ovals and rects, but here's one for rounded rect. Okay, so I'm going to do this rounded rect. It's asking me, where do you want your rounded rect to fit into? So I obviously want it in my bounds, It's going to fill my entire bounds. And then this corner radius is how many points the radius of the turn of the corners is. And for now, I'm going to set that to a magic number, okay? We don't really want blue, okay, which is these literals. We don't want these in our code. These are bad, and I'm going to get rid of that pretty soon here. Why do we not want those? Because if we actually literally have magic numbers like that, we want to collect them all into some area where we have our constants so we can modify them and understand what we've chosen and all that. We don't want to spread all out through our code, so if we ever wanted to change the constants, we're looking around for them. Okay? But for now, we'll leave it this way. All right, so I got my rounded rect. The first thing I'm going to do to my rounded rect, actually, is I'm going to tell it that I want it to be the clipping area for all my drawing. So I've had this nice rounded rect, which is the edges of my card. I don't want to draw outside that rounded rect. Okay, my drawing all has to be inside. Now, I don't think I'm going to write any code that goes outside, but in your assignment 3 you might. Because in assignment 3 you're going to have to draw this squiggle shape, okay, with arcs and lines or something. And then one of the fill modes is striping. So you have to draw stripes in there. Well, imagine trying to draw a stripe that goes from one edge of a squiggle to another edge. It's going to be almost impossible, okay? It would be much nicer if you just have your squiggle be a path, add it as the clip. Now you can draw those lines sloppily, like you're, 2-year-old in a coloring book, draw them paths, and it'll get clipped so it's all inside the squiggle. You see why you want clipping? So here I don't care so much, but I just want to show you what it looks like to call that. Now I want my card to be white, of course, so I'm going to say UI color.white set fill, and then I'm going to fill my rounded rect. Okay, my rounded rect is just a Bezier path, so I can say fill. So let's run and see if this worked, because now, hopefully, we should have rounded rect for our card, and we don't. See, it still has sharp edges up here. See the sharp edges right here? Why does that still have sharp edges? Well, actually, this code worked perfectly. It drew a perfect white rounded rect on a white background. Okay? So we cannot see it. It's sitting on a white background. So we need to go back to our storyboard here and change this so that it's not white background. So what color background do we want for this thing? Actually, we want it to be clear. Okay? Because when we draw a rounded rect, we want to see through the parts of the corners that are rounded to whatever's in the background. So we want it to be clear. But as soon as we start talking about clear and see-through in our view, we need to talk about this switch right here, the is opaque switch. And as I said in the lecture, this is by default on, and it's assuming you don't have any see-through parts, no transparency, and it can be more efficient when it draws. So if we do use transparency, which is less efficient, but we need it here because we need our corners to show through, we have to turn this off. So don't forget to turn that off if you're going to do anything transparent in your view. All right, now we have rounded rects. You see the rounded corners right there, and we have it in both landscape and portrait. Okay, so that's good. All right, we're off to a good start. Now we're going to do our corners. So our corners, remember, are rank and suit. And I'm going to it's actually probably easier to draw the corners with an NS attributed string directly in my draw rect. Probably could do it in 5 lines of code. But instead, I'm going to use 15 lines of code and do it with a UI label. Because I want to show you how you can build your UI view out of other views by making them subviews of yours. Okay? Then we'll do some other drawing with DrawRect, which will also be only a couple lines of code. It's all very efficient to do. So how I'm going to do this on my UI label is I'm going to create a UI label that uses an attributed string as its text. And this attributed string is going to look like this. Okay? So it's going to have, for let's say, let's pick 5 of hearts. Okay? So I'm doing the 5 of hearts, and this is the corner of my big card. So I'm just going to create an attributed string, which is 5 carriage return heart. Okay, that's the attributed string I'm going to create. To make this work, my attributed string needs 2 attributes. Okay, attributed strings have attributes. I only need 2. One is the size of the font. I want to make the font big if my card is big, small font if my card is small. The other thing is this needs to be centered. Because I don't want this 5 over here lined up with the left edge of the heart. I want the 5 centered over the heart, right? And I might have like a 10 of hearts. This 10 might actually be wider than the heart. So I want these two things centered. So I'm going to show you in an attributed string how to do fonts and how to do centering of your text. Okay? So let's create a little kind of utility function, pretty generic function. I'm going to call it, it's going to be private, I'm going to call it centered attributed string. Okay? So what this function is going to do is it's going to take a string and a font size and return an NS attributed string that's centered with that font size. Okay? So it's going to take a string, some string as the string that we're going to do. In our case, it's going to be 5 carriage return heart. And it's going to take some font size. Okay? Font sizes are CG floats, of course. All floating point numbers in drawing are CG floats. And it's going to return an NS attributed string. Okay? So that's what this little function is going to do, because we need that to draw this corner piece. Okay, let's do the fonts first. So I'm going to create a font, and to do that, I'm going to use those preferred fonts, okay, because this card, what's on the card is kind of user information, so I want to use a preferred font, not like the system font or anything. So I do that with UI font, static method, preferred font for text style. And the text style I'm going to use is .body, the body font, because it's really not a caption or a footnote or a headline. It's kind of body text. But I'm going to scale it, and luckily you can just say with size to a font and give it the font size you want, which is this argument to my method. Okay, so this is great. So I've created a preferred font, the body font, and I've scaled it to the right size that I want. I'm going to have to figure out what that size is for my card. But there's one big problem with this. If someone goes on, let's go to the simulator here. Where's my simulator? And if I go over to settings on my device and I go to general, accessibility, larger text, look, I have a little slider that I can change the size of the text in all my apps. Okay, well, all my apps won't include this app unless I deal with the fact that I fixed the font size here. Okay, so what I really want is something that's this font size, but if they've put that slider up, I want it to be bigger, and if they put that slider down, I want it to be smaller. Luckily, there's a great way to do that, which is you can just reset the font to be equal UI font metrics. So this UI font metrics has a great feature in it where you can create font metrics for a certain text style, again, the body font right there, and then you can get a scaled font from another font. So you just give it a font, this one up here that I created, and it will scale it based on that little slider. Okay, so don't forget this line of code. Otherwise, users who are visually impaired, or even just old guys like me who need big fonts, we set that a little higher, and your app is not going to do it. Okay, your cards, your playing cards, are going to still have small text. So don't forget this line if you're doing fonts. All right, how about the centering? I want to center the 5 on top of the heart. Well, we're going to do that with another little type, which is called paragraph style, and I'm going to create an NS mutable paragraph style. Okay, so paragraph style encapsulates all the things about a paragraph, like its alignment and things like that. And so I just set whatever I want in there. Like in this case, I want the alignment to be set, and I'm going to set it to center. So that makes the whole paragraph of text there be centered horizontally. So that's it. Now I can just return an NS attributed string with those attributes, and I'm good to go. So let's use the same exact initializer we used before. So here's the string. That's the argument to the function right here, string. And then the attributes right here, I'm just going to put the dictionary right in. I'm not going to put it in another var or anything like that. Let's just put it in. And so I do NS attributed string key dot paragraph style, for example. Okay, so that's one of the keys, and the value is this paragraph style I just created. And then I can also do dot font of font. Notice I don't have to type this every time. In fact, I don't even have to type it the first time, because Swift knows what type this argument this thing takes, so it automatically will infer that part of this. Okay, so that's it. Okay, not a nice reusable function that will create this kind of attributed string. So now I'm going to create a little private var, which I'm going to call corner string, and it's just going to return a centered attributed string with this, the 5 over the heart. So somehow I need to have my rank plus a carriage return plus suit. And then I'm going to whoa, then I'm going to need some font size. Who knows what that's going to be? We'll have to talk about that because it's got that font size is going to depend on how big my card is. Okay, my card's big, that's going to be big. So we have a couple things to deal with here. One, we need the rank and suit. So the playing card has to have some way to set the rank and suit. Now I'm going to make my rank be an int, and I'm going to make my suit be a string. Okay, now this is different than the model we had. The model had rank and string be enums. Remember that? But who cares? This is a view. It knows nothing about that model. This is a generic card drawing view. It knows nothing of that particular model. So the fact that it represents its rank and suit in a completely different way, perfectly fine. Whose job is it to translate between model and view? Of course, the controller. So we're going to see code in our controller that translates between the model's thought of what a rank and suit is and this view. I don't want to have an initializer there. You see it says no initializer. So let's start with this, 5 of hearts. I'll go grab a heart from over here. Here's heart, copy. All right, so we got 5 of hearts right there. And there's one other thing too, which is this card face up or face down? So I need a is face up, which is a bool, and we'll start with it face up, let's say. Okay? Now, when you have vars like this in a view that affect the way the view would draw, you have to think about the fact that if this changes the rank, your view needs to redraw itself, right? If you change the rank, you've got to redraw. So how do you do that? This is a really great use for did set, okay? So when this rank changes, someone sets the rank to 11, okay, for a jack, we got to redraw. And how do we make ourselves redraw? Everyone remember? Set needs display, okay? So that's going to cause our drawRect to be called eventually. So we can't call our drawRect directly. We just tell the system, hey, we need to be displayed. Okay? Our view has another little thing that needs to happen. We have subviews to draw part of our view. So we need to have those subviews laid out. Now, we're not using auto layout in our subviews. We're putting them where they belong in the corners. But we still need to say set needs layout as well. Okay? So that our subviews get laid out. Now, you don't have to say this if you don't have any subviews that need laying out or that aren't affected by the rank changing. But in our case, it definitely does change the rank. So we're going to do that for all of our little public vars here. Because if people change any of these things, it's going to change the way our card looks. Okay, don't forget this piece right here. Always going to want that, either one of these two or both, on every time you have a public var that someone can change the look of your card. Okay, so now we have rank and suit. Unfortunately, rank is an int, so I can't say rank plus suit. And then also I have this problem with this magic number here. Somehow I have to pick a font size. So in order to speed this demo up a little bit, I actually have a little extension to my playing card. Oops, there it is. Okay, this little extension right here. Okay, this is the entirety of it. It's not very big. And this has captured all of my little blue numbers, my magic numbers, into a struct as static lets. So this is how we do constants in Swift. We make a private struct, we give it a name. Sometimes it might be called constants. I've called it size ratio because all of my constants are about the ratio of the corner or of a font to the size of my car. So I call this size ratio. And then in here I have the corner font size to the bounds height. I have the corner radius to the bounds height. I have corner offset to the corner radius. I have the face card image size to the bounds height. These are all ratios that I've picked that I think will look good. Then I even created some little computed properties like corner radius, which takes the height and multiplies it by the ratio. So here's what it looks like to use a constant that's declared like this. Size ratio dot whatever, or if you had it constants, it might be constants dot whatever. You see how this kind of looks nice right there? Okay, so that's how we do it. So I have these three things, corner radius, corner offset, and corner font size, which will allow me to get rid of blue numbers. And instead, use something that's with respect to the size of my card's height. I also threw this little guy in here, rank string. It's just a var that turns 1 into A, and 11 into J, and 12 into Q, and all the other ones into a number, so that I can have a string. That allows me to go up here when I'm creating this little string right here instead of saying rank plus carriage return plus suit, I'm going to say rank string plus carriage return plus suit. This means carriage return, right? Go to the next line. And so now my font size can be this corner font size. One of these ones I created down here. And similarly, my corner radius right here, which was 16, can now be corner radius. Okay? That's another one of these that I created. Okay? So see how I've segregated off all of my constants into this nice little, I even used an extension. It wouldn't have to be extension, but I just put it off in its own space. Now while I was at it, by the way, I also added some extensions to CG rect and CG point, like zooming a rect or sizing it to something or getting the left half of a rect. Okay? Just for convenience, it's going to make my code look a little cleaner. And you already know about how to do that. We did that with arc4, random, and int, stuff like that. Okay, so we're getting very close to making this work right now. All we really need to do is create these UI labels. So I'm going to create a var for them, private var. I'm going to have an upper left corner label, okay, which is going to be a type UI label. And then I'm going to have a lower right corner label, which is a UI label. Now, I need to create these UI labels, so I'm going to create a little function to do that. Private func create corner label, and it's just going to return a UI label. This is going to be really easy. I'm just going to create a UI label and return it, but I have to do a little bit of configuration of this. We'll get to that in a second. So here, instead of just declaring this label, I'm going to say equals create corner label. Okay? And then here, create corner label. Oops, not reply host. How about create corner label? All right. Now, this is going to, once it catches up to me and compiles, going to create this error. Okay? What is this error right here? Cannot use instance member create corner label within a property initializer. Okay? Well, of course, I'm initializing a property here. And here I'm trying to call a method on myself. And we know that until we're fully initialized, we cannot call methods on ourselves. So this is the old catch-22. So anyone want to say how we can fix this? Okay. Lazy. Oh, good job, everybody. All right. Lazy, exactly. So lazy makes it so these things won't be initialized until they're asked for, which will be after the thing is fully initialized. Okay? So this is equals. All right, so we have this UI label. What do we have to do to initialize our label? Really only a couple things. One is I need to set this var on a label which is number of lines because the default is 1. By default, a UI label has 1 line. So if I have a 2-line thing like 5 character return heart, it would only see the 5. Okay, the heart would not be shown. So I'm going to change this to 0. I could change it to 2, but I'm going to change it to 0. What 0 means is use as many lines as you need, Mr. Label. So I'm setting it to 0. So that's really the only thing I have to say. The only other thing I have to do this label is add it as a subview of myself. Okay? If I don't add it as a subview, then it won't be there. It will never draw. Okay? So I have to add it as a subview. So that's all I need to do to create the corner label. But I need to position these labels. I have to put them in the right place, right? I have to put one in the upper left and one down in the lower right. So where do I do that in my code? Well, I have to do that every single time my bounds changes, especially for the one in the lower right. Okay, the one in the upper left is actually near my origin. It's probably going to be right no matter what my bounds are. But the one in the lower left, in landscape, it's way over to the right and not down very far. And then in portrait, it's way down and only a little bit across, right? So that one in the lower right is moving all over the place when our bounds change like that, when we rotate, or any reason our bounds would change. So where can we put some code that does something when our bounds change? That's what this method, layout subviews, is for. Okay? It's a UI view method. Make sure you call super because UI view is awesome at laying out subviews. It uses auto layout. Okay? All that auto layout stuff we're doing, that's all stuff that UI view knows how to lay out your subviews. Now these two subviews, I'm not doing any control dragging. In fact, I'm creating them in code, right? I created a UI label in code right here. So I have to do the layout myself, and layout subviews is where you do it. Okay? Anytime your subviews need to be laid out for any reason, this is going to get called by the system. You don't call it. If you want it called, you call set needs layout. And set needs layout, the system will eventually call this. Just like if you do set needs display, the system will eventually call this. Okay, very, very similar. All right, so in our layout subviews, all we got to do is move this UI label, okay, this upper left and lower right labels, move them to the right spot. So let's do the upper left. That's a really easy one, actually. So I'm just going to set my upper left corner labels frame. Remember, frame in a UI view is what positions it. Bounds is where we draw. Frame sets it. So I'm going to set its origin basically equal to my origin, but offset by. So I added this little offset by in CG point. It just moves the point over by some amount, offsets it. So I'm going to offset it by this corner offset that I have. So the corner offset, which is one of these things I made from my constants here, that just gets past the little curve. Okay, I don't want to draw this with the curve right here, so I need to move it in a little bit, okay, from the rounded rect. Okay, so that's it. Now, we're not quite there. We've positioned it, but we haven't actually set this string on it. So I'm going to create another little function here. I'm going to call it configure corner label, and I'm going to pass that upper left corner label to it. Okay? And inside here, let's do a little private func. We will pass this label. I don't really need an external name because the name of the function implies the external name. It's UI label. Okay, so here I'm going to configure it. And I don't actually have to do very much to configure it. One thing I for sure need to do to this label is set its attributed string, or attributed text rather, to be my corner string. Remember, corner string is this thing up here. This little guy just gets a centered attributed string with the rank string character return suit of the right size, depending on how big our card is. So I definitely need to do that. What else might I need to do to my label when I do this? Well, one thing is I want the label to be the right size. Okay, I want it to be kind of the perfect size to enclose this thing. Luckily, label has a method called size to fit. Okay, and it will size the label to fit its contents. The only tricky thing about this, though, is if that label already has some width and you say size to fit, it will make it taller and keep the width. Whoa, we don't want that. Okay, we want it to do the whole thing. So I'm going to say label.frame.size equals cgsize.0. Okay, so I'm going to clear out its size before I do size to fit. That way it'll expand in both directions. Okay, across and down. So that's a little trick about size to fit you got to know there. And the last thing, really tricky thing, is what about if we are not face up? Do we draw these corners in not face up? Of course not. Okay, we don't want the back of the card to have that would make it really easy to play a lot of games if the back of the card had the corners on it. But we don't want that. So I'm going to configure the label to be hidden, not highlighted, hidden, if we're not face up. Okay, so if we're face down, then I'm going to be hidden. So here's an example of using hidden. It keeps it in the subviews list and everything, keeps it the right position, just hides it. Okay, instead we're going to draw the back of our card, whatever that looks like. Okay, it's a good example of using is hidden right there. Okay, should work. Let's take a look and see if we can get that upper, at least this upper left one to draw. There it is. 5 of hearts. Looks good. Let's see if it works when we go to landscape. Whoa, not only right position, but look, it's smaller because the card is shorter, so we don't want to use half the card with our big font. Okay? So that's good. What about the other corner? Okay, well, the other corner is a little harder to position because, you know, our origin's in the upper left and we're trying to put it way down in the lower right. But it's not that bad, so let's try and do it. This is our lower right corner label. It's frame.origin. Well, I'm going to build this incrementally. I'm going to start by making a point, which is my bounds.maxx. Okay, so all the way over to the right. And y is my bounds.maxy. That's all the way down to the bottom. Okay, but I can't put it there. If I tried to put it there, here, let's draw a little picture so you can see. I'm drawing the lower edge now. Okay, here's my lower edge of my card, and I'm trying to put this thing here. So I can't put it here. If I put it where this would be the origin, it would be down here, not even on the card. So I need to move this point first inside the corner offset, then the whole distance of the width and height of this little thing. So I need to kind of make a double jump here to get this origin up here, so this will draw there. Okay, so I'm just going to do a double offset by. The first offset by I'm going to do is minus corner offset and minus corner offset. That gets me past the rounded rect. Then I'm going to offset again, minus the lower right corner label's frames size width, and minus the lower right corner label's frame size height. You see how I've had to move the origin back up there? Everybody cool with that? Okay, so that positions it. This is wrong corner offset, right? So that positions it. Of course, we've got to configure it as well. So let's just do the exact same thing here, but we're going to configure our lower right because it needs to be configured in the exact same way. Okay, it needs the corner string, whatever. So let's see what this looks like. Oh, lower right. Oops, I didn't finish there. Lower right corner label. All right. Okay. Whoa, interesting. Well, that's not quite right, is it? Okay, it's in the right spot, but that 5 hearts should be upside down, right? If you look at a card, a playing card, that would be upside down. Okay, so how the heck am I going to turn that thing upside down? Well, that turns out to be super easy in iOS because every view has a var on it. Lower right corner label has a var on it called transform. Okay, and transform is what's called an affine transform. How many people know what an affine transform is? Okay, nobody, basically, almost. So an affine transform is really simple. It's just a blob thing that represents a scale, a translation, and a rotation. Okay, just those 3 things. So you can take a UI view and rotate it, scale it, and translate it all you want with just this one little var. Now, of course, we are positioning things with the frame and stuff like that, but this is an additional way to control its positioning, scaling, and rotation. Now, this is all going to be bitwise translation, okay? So it's going to be translating the bits. So if you make it bigger, it might look kind of jaggy-edged, pixelated, but we're not going to make it bigger. Instead, we just want to rotate it, okay? But so you might think we could just do this. Let's take the affine transform identity transform, okay? So that means unrotated, unscaled, untranslated, just an identity. And you think I could just say rotated. By the way, transform only has 3 methods: rotate, translate, and scale. That's all it's got. So if I created a rotated one, how much would I want to rotate this if I wanted to turn it upside down? Okay, in radians. Pi, right? Because I want to turn halfway around, okay, so it's upside down. So I could just say cgfloat.pi. But this would not actually work. This is close, but it doesn't work. So let me show you why that's not going to quite work. Show you a piece of paper here, we'll do this. Okay, so here's my corner right here, and here's where this 5 hearts thing is right now. It's up, right side up like this. Actually, here, we'll do it on a piece of paper. So here's my 5 of hearts, and I want it to be upside down like this, right? Okay, that's what I want. But if I rotate it, it rotates around the origin. Okay, and our origin's upper left. So if I rotate it pi, whoop, it's going to be up there. Do you see the problem? So it will be upside down, but not in the right place. So I need to both rotate it and translate it. So what I'm going to do is I'm going to translate it first down to here, to its other corner. Then I'm going to rotate it. Woohoo! It's going to work. Okay, so let's do that. Where are we? Where's my rotated? Here's the rotated. So I'm going to keep that rotated. I still want to do, dot rotated. But I want to do a translate first. So I'm going to say dot translated by, and how much do I want to translate by? I want to translate by the whole width and height of my lower right, lower right corner label dot frame dot size dot width, and the lower right corner label frame dot size dot height. Okay, so I'm taking the identity, I'm translating it down to the corner, then I'm rotating it. I could also have kind of translated it to the center and rotated it and then moved back. That's another way commonly to do that rotation. But here we go, it's upside down, and it works even in other bounds sizes. Okay, excellent. So we've used a subview. We've used layout subviews to make it always be in the right position. All is looking well. Let's go check and make sure that our slider, remember this slider over here in settings? Remember we can set it larger? Let's go make sure this is working. I'm going to set this to quite a large size font. And hopefully when I go back to my app, right, it should have a large font, but it doesn't. Why doesn't it have a large font? That is weird, okay? Well, actually, it does. It's just it never redrew. If I change my bounds, okay, and flip back, now I get to see the large font. So that's a problem, okay? When that slider moves, we need to find out that it moved. And you can do that in View with a function called trait collection did change. Trait collection did change. Okay, so traits, we're going to talk about traits in a couple weeks. Traits have a lot to do with, like, are you rotate, are you landscape, are you portrait, things like that are traits, but also your size category in general for your fonts. So trait collection gets called whenever those things change. So here I'm just going to set needs display and set needs layout. Okay, so if my traits, the thing that control how I draw, change, then I'm going to redraw. So now, if we go back, right now our fonts are big because we set them big, so they're going to start out big. And if I go back and set them to be small over here in my settings, go back to normal size. Oops, sorry. Got that? What? There we go. So set it back to normal. Let's go here, go back to our playing card, and it redrew it normal, okay, because it found out that that slider had moved. Okay, so minor little thing you got to remember to do this. And we'll talk about, a lot more about traits down the road. Okay, let's go back and do a little bit of layout stuff. Take a little break from drawing our card and do layout. So right now we've got this thing where this card takes up the whole space. Actually, I'm going to make the card white again so we can see it a little better. So I'm just going to go back here and make it white. So this card is not really card-shaped, okay? Cards are not tall and thin like that. And cards are definitely not like this card over here. No cards look like that, okay? So that's ridiculous. We don't want that. We want it to look more like a card. And what makes a card look like a card? Well, it's its aspect ratio, right? The width, the relationship of the width to the height. So we want to change that. So to do that, we can't have the edges pinned to the edges anymore. So let's take our constraints that pin it to the edges, and instead of making them pinned, let's make them be greater than or equal so that our card doesn't go off the edges, but it's not pinned to the edges either. So how do we do that easily? Well, you can find out all the constraints that are on a view by just selecting it and going to this other inspector on the other side of your attributes inspector called the size inspector. Okay? See, here's my constraints. These are my 4 constraints. Even as I mouse over them, look, they highlight. So right now they're all equals. They're pinned. Okay? Equals 16, pinned to the edge, equals 16. You can change that equals just by editing them and changing it to greater than. We actually did this last time. Okay? And we could do that for all of ours. Let's make them all just be advisory. And let's not do the bottom right up against the bottom. Let's go ahead and just do greater than or equal to. And same thing here, greater than or equal to, and we'll do 16. So it's at least the same on all sides. So now these constraints on the edge are just advisory. They're just saying, make sure you don't go past 16 points from the edge. So that's great. But now the lines are all red. You see how everything's turned red? That's because we no longer specify where this card's supposed to be anymore. Okay, since we're not pinning it to the edges, where it's supposed to be. Well, let's first fix this aspect ratio problem. Okay, I want the card to have an aspect ratio, you know, kind of like that or so. Basically 5 across to 8 down seems to be typical card ratio. And it turns out you can fix the ratio of a view by doing control drag. But you don't control drag to another view like we do when we're pinning to the edge. You control drag to itself. When you control drag to itself, you're offered the option of fixing the width, the height, or the aspect ratio of this view. So I'm going to fix the aspect ratio. So now I've added a constraint. Look at it over here. that fixes the aspect ratio. Now, of course, I don't want the aspect ratio to be 259 to 461, so I'm going to edit it to make it 5 to 8. Okay? So I fixed this aspect ratio. This still doesn't say anything about where the thing is supposed to be or what size it's supposed to be or what, anything like that. So let's put another constraint that says it's going to be right in the middle. So you see how I use the dashed blue lines to drop it perfectly in the middle? Now I'm going to control drag from the card back to my outer view right here. And this time, instead of doing trailing and top, which I already have those greater than or equal to ones, I'm going to pick center horizontally and vertically. And you notice this says horizontally and vertically in safe area. Okay? So every view knows its safe area. Its safe area is the place it can draw without overriding or impinging upon other views' space. So for this orange view, its safe area does not include this place where the facial recognition and the time of day, all that up here, so it wouldn't draw up there. It also does not include this little bar down here. If there were bar buttons along the bottom or a title across the top, it wouldn't include that either. And that's all automatic. And not only automatic, as it changes, these constraints will automatically adjust to that. So if you put a title on the top of this view and its safe area moved down, then our card would move down to be in the center of the new safe area. Okay, so that's what safe area is all about. We always are creating constraints between views' safe areas. All right? Okay, so now I've said where it is, but things are still red. Okay, why are things still red? Well, because I haven't said how big this view is. I've said what its aspect ratio is and where it is, and I've said that it can't go past the edges, but I haven't said what size it is. A very small card would satisfy all these constraints over here. Right? A very small card wouldn't be going off the edges. It could be the right aspect ratio. It could be in the middle. Or a larger card that doesn't go off the edges could fulfill all these, right? So how do I tell the system, I want you to be as big as possible and still satisfy these? Well, I'm going to do that by pinning, by dragging to myself, my width. And I'm going to set my width, which is currently 259. I'm going to edit it. By the way, that fixed the problem because now, look, now no red because I've said how wide it is. But I want it to be bigger. I'm going to say I want it to be, let's say, 800 wide. Okay, now as soon as I tried to have a constraint that said this is 800 wide, whoa, we went red again. Now why are we red? Well, we're red now because these constraints cannot be satisfied. There's no way it can be 800 wide and also not go off the edge, basically. So that's a problem. Now how are we going to fix this? Well, all these other constraints besides the width, I got to have those. If I don't have those edge constraints, it could go off the edge. Got to have it. Aspect ratio, that's what I want my card to look like. Got to have it. In the center, I definitely want the card in the center. Width, well, I wanted it to be 800, but really I just wanted it to be big. So that 800 width is not as important to me. In other words, it's lower priority constraint. So I can tell the system that by going over here and editing this constraint and changing its priority. You see priority 1000 right there? That is the max priority. That is required priority. So we can pick any priority less than 1000 because all of these are at 1000, and this will be less important. So we'll still try to satisfy it as best it can, but it won't override any of the other ones. So we do that by clicking on the priority. We could type a number, or we can pick some kind of well-known ones like high priority, and whoa, look what happened. All the red went away. It made the thing as big as it could. It's still satisfying all the constraints. It's doing that both here and over here. See, it made it as big as it could and still have that 5 to 8 aspect ratio in the middle and in the middle. Okay? So that's the magic of constraint priorities. Okay? Making constraints that don't matter as much have lower priority. The system will still try to give you as much of them as it can, but it will give in on those lower priority ones. Everybody cool with that? Okay, so now we got this thing looking more like a card. It's got a card aspect ratio. So let's turn it back to clear here. So we can go back to drawing it because we still have only done the corners and we need to do the rest. So let's next do the face in the middle of a face card. Okay, so we have a face card, we need some kind of image. Now I'm going to do that by drawing an image, and I just happen to have over here somewhere, not this guy right here, face cards, a bunch of face card images. Woohoo, okay? And I'm just going to drag all these images into my project. Well, where do I put them? That's what this assets.xc assets is for, the place where the app icon was here. You can drag any images you want in here. So I can go grab all of these images, drag them all in. Now when I do that, it looks like some of them didn't come in. These ones that say @2x, you see, @2x, oh no, those didn't drag in. Well, yes, they did. That @2x means it's the same as the one that doesn't have @2x, but it's twice the resolution. So it put them as a 2x version, twice resolution. Now, some devices have 3x resolution, like iPhone Pluses, for example. I don't have any cards at that resolution, so it'll fall back to using the 2x resolution, but I probably should add 3x resolutions to all my cards. Now, these JPEGs that I dragged in, this is telling me the name of it, and it got it from the file name of the JPEG, but you can rename these to be whatever you want. I've conveniently named them rank suit, okay, so that I can find them. And putting these images in my face card is just a matter in my draw rect of looking these up by name. So let's go to our playing card view, back to our draw rect where we draw our rounded rect here. Now we're going to say if we can let the face card image equal, I better go wide here, equal UI image. So UI image is the thing that represents an image. And if you look at its constructors, it has quite a few. But one of the ones it has is named. Okay? And now you just specify the name, and this name has to match this name that's in XC assets over here. Okay? So that is our rank string plus our suit. Okay? So that is the name. So if we're able to find that, then we must have found a face card. So now we're just going to put that face card image, draw it, and we draw by saying .draw in, and I'm going to draw it in my bounds, but actually I don't really want to draw that face card in my full bounds. It might smash into the corners, right? So I'm going to take that bounds and zoom it down a little bit by one of my constants down here, this constant right here. So this is size ratio dot face card image size ratio, and I currently have it set to be 75%. So I'm going to have my face card be 75% of the full size right there. And that's it. That's all you need to do to draw images. Really easy to get them by name and then just draw them in some rectangle. So let's go change our card to be a face card. How about, let's say a jack. Okay, 11 is a jack. Make sure this draws, and it should be 75% of the size of our card here. There it is. It is. And when we rotate, it draws it smaller, okay, because it's drawing it compared to our bounds, which our bounds are changing when we rotate. Okay, so that's super cool. What about pips? So what if we back to having the rank be 5, then in the middle we draw 5 hearts, 5 little hearts. Well, I'm not going to waste our lecture time going through code that does that because it's pretty straightforward code. You're not going to learn anything new. You can certainly look at it offline. I'll be posting this code online. So I have it right here, though. It's called draw pips. Okay, so there's this function draw pips. The way it works is data driven. So like for the 5, it goes 2 pips, and then 1 pip in the middle, and then 2 pips at the bottom. All right, or an 8 is 2, 2, 2, and 2, etc. So it's just data driven. And it literally just does a for loop and goes through the for loop and draws either 1 pip or 2 pips and just goes down and draws however many rows there are. It does have this kind of cool little embedded func. You notice that functions can be inside functions in Swift. This create pip string just creates an attributed centered string, but it doesn't have the 5. It's just the pip part of it, but it's still centered, which is nice, so it draws it in the center of the card. And it kind of picks the size by guessing what the right size would be and seeing how big that is and then adjusting it so that it picks the perfect size pip to fit the space that's available. So you can look and see how I do that using centered attributed string there. Okay, that's pretty much it. So if it's not a face card, then we want to draw pips. So let's see if that works for our 5. Okay. Looks pretty good. And let's see, we rotate it, smaller, it all got smaller. Okay? So easy to do this stuff, right? Okay. Now we kind of are at a point with this thing. Well, there's one other thing, sorry, we have to draw, which is the back of our card. Okay? So it really should only do this stuff if it's face up. Right? It should only do the face card and the pips if it's face up. And we already made it so that if it's not face up, it hides the our little labels, right? Is hidden, hides our labels. So that's good. But if our card is face down, then we need to show the back of the card. So I'm going to do that with an image as well. I'm going to say if let card back image, not capital I, image, equals UI image again, named, and I'm going to call it card back. So I'm going to look for an image named card back, and if I can find it, then I'm going to have draw in, and this time I am going to draw it in my entire bounds because it's not going to hit any corners. The corners aren't there because I'm face down. So I need an image named card back. So I'm going to go over here to assets, and I have to put an image called card back. So I'm going to grab this image right here. This is my Stanford image, and I'm just going to rename it right here to card back, so that it's my card back. Notice it only has the low resolution version there. I didn't have an @2x, but I can drag higher resolution versions in to provide higher resolutions, just like that. And this one's so high resolution, it's got a little tree in there even, okay, and that's perfectly fine. No law, it says has to be just a scaled up version of the same thing. So now I have card back there. So now let's go and make our card be face down by setting our is face up here to be false, okay, and run. And we'll see the back side of our card. And hopefully we don't see any corners, we don't see any face, we don't see any pips, we won't see any of that stuff. We'll just have the back of our card. Okay, and this is a high resolution device, so we got the 2x version. And you can see it's actually kind of jaggy. We really could use a 3x version here, it would be nice. Okay, now the next step if I were really developing this is I would want to go up here to my rank and suit and try every rank and every suit face up and face down, and make sure it's all work. Well, can you imagine if I had to do this? Okay, make this a 6, and then clubs, and run. No, okay, so it's 6, 7, and run. It would be tedious as all get out to be going back and forth running. What would be awesome is if I could just see this playing card view right here in Interface Builder. And of course I can do that. I wouldn't have mentioned it. So let's go here, and how do you do that? You just put @IB Designable in front of your view. If you put that in there, then when you go to Interface Builder, it will compile your view, put it in the environment, and put it here. Now, it's blank. Why is it blank? Well, it's actually blank because it's face down, and images don't work with image named in Interface Builder. For example, if I put this thing face up again, you'll see that it works with the pips because they don't use any images. I go back to my storyboard. Look, I got pips. I got my corner things too. Okay, so it even does subviews. So what about those images? How am I going to do the images? Because that's a problem not just for the card back, but if I make it be a face card, the face card is made with images, and so I'm getting the corners, but I'm not getting my image. Well, it turns out there's another version of image named that you can use that will work with both. Okay, so it'll work image named when you run, but it'll also work with image named when you are in Interface Builder environment. Okay, and it looks the same. I can never even remember it myself, so I had to write it down here. It's in bundle for self.class for coder, comma, compatible with trait collection. Okay? I think I typed that right. So this is the extra couple arguments you need. You put it on all your image names if you want this stuff to work in Interface Builder. So now if we go to Interface Builder, all right, it's showing the image. But this is only half the battle because if I want to look through all my cards and make sure they're working, I still have to go back here and change these ranks and suit and then go back and see it again. What would be really cool is if I could bring up the inspector, click on my card, and instead of just seeing view attributes, if I could see rank and suit and his face up. Wouldn't that be awesome if I could just like extend this inspector? Well, of course we can do that too. All we have to do is put @IB inspectable in front of any var that we want to be inspectable in Interface Builder. So I'm going to put it on all my vars. Okay, we'll make them all be inspectable. The only trick here is that you have to explicitly type any IB inspectable. You cannot let this be inferred by Swift. Because while Swift is good at doing inference, Interface Builder not so much. Okay, not quite so good. All right, so here we go. Now if I click on my view, look at this. Rank, I could try 5. Okay, or I could try 12. All right, I can try 2. I can even just go all through my cards, like this. Okay, and since I've represented my suit as a string, I could even have X be my suit right there. Okay? That works? Okay, so that's it for all the drawing stuff. Let's go back now and learn a little bit about multi-touch. So I'm going to go back to our slides here. And we're running a little late, so I'm going to zoom through these. All right, so we've seen how to draw. Now, how do we get multi-touch? How do we get all these gestures and stuff people can make with their fingers on the screen? And you could get all the touch events yourself. That's legal. You could. And look at them, look at every finger when it moves, but that'd be incredibly tedious, so we don't do that. Instead, we let iOS look at all those little movements and turn them into gestures, like swipe, pinch, pan, tap, okay? So that's the level at which we program this stuff. Okay, now gestures are all represented in iOS with this class UI gesture recognizer. It's a thing that recognizes a gesture from all those finger movements. All right, that class is abstract. Okay, it itself doesn't know how to recognize any gestures, but there's a lot of subclasses of it that know how to recognize various gestures. Okay, so when you're recognizing a gesture, there's actually two parts to it. One is you have to tell a view, please start recognizing pinches. Please start recognizing taps, okay? Then you have to provide a handler so that when it does recognize it, it calls some function, okay? So there's two parts. The first thing, asking a view to recognize a gesture, is surprisingly often done by the controller or in your storyboard, okay? That's how you add gestures, usually. Sometimes a view will add a gesture recognizer to itself if it's just totally inherent to what it does, like a scroll view will add pinching and panning gestures to itself because it's not even a scroll view without those gestures. But a lot of times it's the controller does it. The second thing, the handling of the gesture, if it's something that affects the model, then the controller is going to handle it. If it's something that only affects the way things are viewed, then the view will often handle it directly. Okay, so we'll see examples of both of those in our little demo. So how do you add a gesture, the first part, how do you add a gesture to a view? How do you tell that view, start recognizing this? Well, usually we do this in the did set of an outlet setter. So here I've got an outlet to some view that I want to recognize pans. Okay, it's some view and I want it to recognize pan gestures. So in the did set of the outlet, remember this did set is called when iOS wires up that outlet to the view that you want to pan. Then I'm going to create a concrete instance of UI gesture recognizer called a UI pan gesture recognizer. Now all of the recognizers have the same initializer. It has two arguments. The target, that's the object that is going to handle this. It's usually either the controller or the view itself. And then it has the action, and that's just the name of the method with hashtag selector around it. You see that hashtag selector in yellow there? That is going to be called when this gesture starts to recognize a pan happening, okay? So then, once we've created a UI pan gesture recognizer, we ask the view, please start recognizing this. And we do that by calling add gesture recognizer. And a view can have as many gesture recognizers as you want. It could be recognizing 20 different gestures at the same time. It's perfectly fine. All right, so now let's talk about the handler. So when a pan starts to happen, a handler is going to get called. And the handler is going to be that pan method that we saw over there. And inside that method, we're going to have to be able to get information about the pan. Well, each kind of gesture has its own information. Like a pinch gesture has the scale you're pinching to. A pan gesture is where is the pan happening. So if you look at UI pan gesture recognizer in the doc, you'll see it has methods like translation in view. That tells you where the pan is in that view. Okay, or velocity. How fast is the pan happening right now? Or even set translation, which lets you reset that translation in view so you get incremental panning instead of the continuous length of how far you've panned since the start of the pan. You get how much you got since the last time the pan moved, okay, which can sometimes be useful. Now the abstract superclass, UI gesture recognizer, it also has a very important var called state. So this whole gesture recognizer thing is a state machine, and this state var represents that. So as soon as a gesture becomes possible, okay, like a pan, probably a finger touches down, now it's possible, and then as soon as it moves into the began state. Okay, so this pan has begun. And then as the finger moves, it stays in the changed state, but it really keeps moving to the changed state from the changed state over and over. Now, every time one of these state changes happens, that handler gets called. Whoever's handling this thing gets a chance to do it. So for a pan gesture, you get dot changed called every time the thing moves. And then eventually the finger goes up, and it ended, and you get dot ended. Okay? So your handler is just called every time the state machine changes. Now, some things like a swipe are discrete. Either the swipe happened or it didn't. You don't get dot changed as your finger is flying across the screen. It's a discrete gesture. You just get dot ended, or for a swipe, dot recognized. It gets sent to your handler once, and that's it. Okay? But for continuous gestures, you get the dot changed. Now, there's also two other interesting states, dot failed and dot canceled. So dot failed can happen when you have multiple gestures and one of them wins. Okay? Like let's say you have, I don't know, a tap gesture and a pan gesture. Well, as soon as you go mouse down, it could be either of them, but as soon as it doesn't come right back up, as soon as you touch down, as soon as you come back up, it's like, oh, it can't be a pan anymore, so that one's canceled. Okay? It failed, basically. So it can go into failed states, but that's only if it actually starts up. It wouldn't even be recognized in the first place if it didn't get that far. And then canceled is another one that's interesting, and this happens a lot with drag and drop, okay, which is you started something, and it started up, and it's going good, but then a drag and drop happens, and now it's canceled, okay, whatever gesture you were recognizing. So you do want to look for failed and canceled and make sure you clean up or whatever, take away something off the screen or whatever, because your gesture has failed or has been canceled by something else. All right, so given this information, what would our pan handler, okay, the handler for the pan, look like? Okay, so it's just pan with the argument being the pan gesture recognizer itself handed back to us. And we switch on the state. Okay, we always switch on the state. And if it's changed or ended, and notice I'm using fall through there, but I could have just said dot changed, comma, dot ended there. So if it's changed or ended, my pan is still moving, or I just finished it, then I'm going to find out where the pan was by calling translation in view on the recognizer. Then I'm going to do something based on where the pan went. Okay? And maybe if I'm looking for incremental pans, I'll reset it back to 0. So the next one will be from 0 and be incremental. Okay? So that's it. Simple to do these handlers. Now, what are some of the concrete handlers besides pan gesture? Well, there's pinch gesture. Its information is the scale. Okay? So if I start here with a pinch and I go twice as wide, well, that's scale 2.0. If I start here and go half as wide, it's 0.5. And there's also velocity for that one. There's rotation gesture, which is like turning a knob, a two-finger gesture, turning the knob. And in radians, it'll tell you how much the knob has been turned in radians. There's a swipe gesture, and you can, now swipe is a little different than these other ones in that you configure the swipe, how many fingers, what direction, left, right, up, down, and then you turn the swipe gesture on by adding it, and then when the swipe happens, you'll just get dot ended. Your handler will get called with the dot ended. Okay, so it just, there's no, it's different in that you configure it up front, and then it just tells you whether it recognized it or not. There's tap gesture, which feels like it would be like swipe, a discrete gesture, but actually since it does double tap and other things, you're always looking for dot ended only with a tap gesture usually. But you also configure it like a swipe gesture, how many taps, how many fingers, etc. There's also long press. Okay, long press is you hold your finger down on the screen for enough time and it starts recognizing it. This is surprisingly a continuous gesture because as you're holding it down, your finger might be moving a little bit, and that's okay. It's not a pan, okay, because it can only move a little bit. But if it does move a little, you'll get dot changed, okay? And you can configure how much movement you allow and how long it has to be pressed before it's a long press. This one gets interrupted a lot by drag and drop because drag and drop uses long press, okay? That's how you pick something up with drag and drop is long press. So if you have a long press and there's some drag and drop going on, you know, the system's very smart about figuring which one you actually intend, but it could cause your long press to be canceled. All right, so let's see all this in action with a demo. We only have 5 minutes left. I think we can do it in 5 or 10 minutes. We're going to add 3 gestures to our playing card. We're going to add a swipe, which is going to flip through our deck of cards. So that's going to affect our model. Our model is that deck of cards. So that's something our controller is going to have to do. Then we're going to have tap, which will turn the card over. We're going to do tap by adding the gesture in the storyboard, not even in code. And then we're going to have pinch, which I'm going to use to resize the face card faces, okay? And that's a view-only thing, so the handler for that will be in the view. And since I won't be back to the slides, on Friday, no section again. Homecoming week this time. We have conflicting schedules, so we couldn't do section this week, unfortunately. Next week, we'll start doing multiple MVCs, view controller lifecycle, and hopefully we'll get into animation as well next week. All right, so here we are. Let's make our thing look a little better. Let's go get back and get a nicer thing, maybe clubs this time. Go back here. Instead of X, we'll have our clubs. Okay, so we have nice looking cards. And let's do the swipe first. So the swipe, to do the swipe, let me get both our controller and our view up on the screen at the same time, okay? So here's our controller. It just has this deck of cards. It doesn't really do anything. I want to add a gesture to this playing card view that is swipe. I need an outlet to it. Okay, my controller can't talk to that thing with an outlet. So I'm just going to control drag like I would drag anything to make an outlet. Click it here. It's going to be an outlet. It's going to be my playing card view is the outlet. Here it is. When this gets wired up, I'm going to immediately add a gesture recognizer. So I'm going to do that in the did set of this so that when iOS sets it, I get to execute my code. I'm going to do a swipe. So I'm going to create a swipe gesture, UI swipe gesture recognizer. And the constructor is this target action thing. Okay, since swipe is going to flip through the cards, it's going to affect the model, so it has to be handled by me, the controller. Okay, so self is the target. The view can't touch the model, so there's no way it could do the swipe. And then the selector can just be any function. So I'm going to have a function here called next card, which goes to the next card. It's not even going to have any arguments. That's going to be the action I want to be called when a swipe happens. So I just say hashtag selector, and then I give the name of it, next card. It has no arguments, but if it did, I would just put the args, okay, in there, but it doesn't have any arguments, so I don't need that. Okay, selector next card. So that's my swipe gesture. Now I need to configure the swipe gesture. So for example, I can set its direction. I could set it swipes to the left, for example, swipes to the right. You could even say swipes to the left or right. You can put a little array notation there for left and right. So now I've got my swipe. It's going to be a single, what do we got? Oh, yeah. So this is an error right here. I'm going to click on it. It's going to cause our screen to get all wonky here, so let's move it around. Let's look at this error right here. It says, the argument of hashtag selector refers to an instance method next card, which it does, that is not exposed to Objective-C. Oh my gosh. This whole mechanism is built on an Objective-C mechanism of target action. So any method that is going to be the action of a gesture recognizer has to be marked @objc. That exports this method out of Swift into the Objective-C runtime, which underlies the running of the iOS. Even with Swift code, still got the Objective-C runtime. Okay, so that's what that's all about. This always has to be just marked at objc. It's not that big a deal. Just got to mark it. All right, let's go back to our split screen here. This and this. Rearrange everything. Back to automatic. All right. So now that we have this swipe gesture recognizer, we need to ask this playing card view, please start recognizing it. So we say playing card view, add this gesture recognizer, swipe. And now it will start recognizing it. And that's all we need to do. Now, this next card is the thing that's going to flip through our cards. So how do we implement that? I'm just going to say, if I can get a card out of my deck, okay, because my deck might be empty, that's why I have to do if let there. Then I need to set the playing card view's rank equal to something, and I need to set the playing card view's suit equal to something. Now, here's where the controller is doing its job of converting between the two, okay? So we're going to convert by saying the card's rank. Luckily, we have order, which does the card's order, and card suit has its raw value. Okay, so this is just converting between the model and the view there. Everybody got that? So let's give it a try, see if this works. So this should swipe through random cards by doing swipes. So here we go, swipe. Sure enough, look at that, swiping through. So that was really easy, right? Just had that deck. All we had to do is just set the playing card view to show a different card each time. All right, the next thing we're going to do is tap to flip the card over. Okay, so tap, I'm not even going to do this code right here. Instead, I'm going to go over here and grab a tap gesture from, for this view, from here. It's down towards the bottom. Look at all these gestures, pinches, rotations, swipes. Here's tap. And I'm going to drag it to the view I want to recognize a tap, which is my playing card view. I drop it, and it shows up. If we zoom in, you can see it right up in this title bar up here. You see that right there, tap gesture? You can click on it and inspect it, right? How many taps, how many touches. You can also control drag from it to set an action. So I'm going to set an action here. I'm going to call it flip card, because that's what I want it to do, flip the card. I want to fix that anything, just like any action, I want it to fix the argument. So here's my flip card. And inside flip card here, I'm just going to say playing card view.isFaceUp equals not playing card view.isFaceUp. Okay, I'm just going to flip the card over, and that's it. So some gestures are really easy to write. And actually, I abbreviated that a little bit. But now if I click, you see how it's flipping it over. Okay, now I know we're rushed, but actually I'm going to do the right thing here. This really shouldn't be like this. I should switch on the sender, which is the recognizer's state, and make sure that we are in the ended case to do this. Okay? Now, it'll usually work to not do that, but I don't want to show you something that's really kind of not correct. Okay? And then the last one we're going to do is pinching to set the size of the face card. Well, to do that, I need to go back to my my custom view over here, and I need to make it possible to change that. So right now, actually, let's go here, view. Okay, so right now, the size of my face card, remember that's a constant, this size ratio, face card, image size to bound size. So I'm going to change that to be a var. I'm going to call it face card scale. Okay, so I need to create a new var to do that. So let's go do it all at the top so we can easily see it here. Var face card scale. It's going to be a CG float. I'll set it equal to that constant. Don't forget to do this. Okay, although we don't really need set needs layout because changing the card size, the face card, does not affect the corners. Okay, so I don't need to relay out. Okay, so I've got that face card scale. So now I'm going to create a little func that is going to be a handler for a pinch gesture. Okay, I'm going to call it adjust. I had a good name for it here so that's easy to understand what it is. What did I call this thing? Adjust face card scale by handling gesture recognized by recognizer. Okay, UI pinch jet. Now, I did this intentionally long name there so that you would understand that this is a handler for the gesture. And since it's a handler, it needs to be @objc, of course. And inside here, I'm just going to switch on the recognizer's state, as I always do. That's what we do in standards in these handlers. And if it's changed, so the pinch has changed, or if it's ended, then I'm going to set my face card scale, this thing I just created up here, okay, to be times equaled the scale of the recognizer. Now, I only want incremental changes because I'm changing the scale each time. So otherwise, it would be just starting to be exponential. So I'm going to reset the recognizer's scale to 1.0 each time that this happens. And then we're going to ignore all other states of the state machine. Okay, we don't care when it began and all that stuff. Okay, so now we're going to have this adjust face card scale by handling gesture recognizer be added back in our controller as a pinch gesture. So here I'm going to create a pinch gesture. Let pinch equal UI pinch gesture recognizer. Same target and action thing as the other one. But this time the target is going to be the playing card view. It's going to handle this directly. It's not going to go to the controller. And the selector is that method we had over there, okay, that's in our view. And I'm going to call it pinch, okay. And now I just need to tell the playing card view to add this gesture recognizer pinch, and it will start recognizing. Okay, so let's take a look. Oops, what did I do wrong here? Oh, no, what does it say? Unresolved. Okay, let's use escape completion here. Adjust, sorry, playing card view. I need to say that it's in PlayingCard view. That's the problem there. Handler, okay, sorry about that. Okay, so let's find a face card. Here it is. How do you pinch in the simulator? You hold down Option, you get these gray things, and when you mouse down, you get to pinch. Okay, so see how that's only affecting the view. It's not affecting anything else. Affects all the cards. And that's it. Okay, sorry to rush that at the end. You'll be doing all this stuff in your assignment number 3, which just went out. It's due in a week. In other words, before lecture next Wednesday. And I will see you all then. Actually, I'll see you on Monday. And if you have questions, I'm here, as always.
For more, please visit us at stanford.edu.